Last week, we graphed a line by plotting points. We picked x values and found the corresponding y values that went with them. So I'm going to pick x equals -1, 0, 1, and 2. You could pick other points. I'm just picking these so that I can get a good idea of my graph. So I'll use my equation, and I'll sub in my x values to find what the y value is. 2 times -1 is -2, plus 1 is -1. So there's 1 point on my line. If I plug 0 in, I get the point 0, 1. If I plug 1 in, I get the point 1, 3, and so on. I'm an awful straight line drawer, sorry. So again, when there's two variables, an x and a y, you have many solutions, and those solutions form a pattern which can be graphed. When the equation looks like this, y equals some number times x plus some number, that's always going to give us a pattern of a line, a linear equation. We call this slope-intercept form. We'll talk a little bit later about why that name exists. The m number is always the coefficient of the x term, and the b number is always a constant term. When lines are in slope-intercept form, there are patterns to what the m and the b number control about the equation. I'm going to go back and forth between this website and our notes so that we can quickly graph these lines. So when I go to this website and show the graphs of these lines, you graph them on your notes. This website is an activity where you can move the m and the b number to quickly show what a line is going to look like. So this will be the m number, here's the b number, and on the bottom it shows us what our equation is. So we're going to take a look at the 4 equations on the bottom of the first page in the notes. So on all 4 of those equations, the m number is 2. So we'll set the m number to 2. And the first one, the b number, is 1. Notice that that b number right there is where the graph of the line crosses the y-axis at +1. Watch what happens if I change that to a 3. Change the b number to a 3. It moves my line. Now my y-intercept is at +3. If I change it to a -2, now my y-intercept is at y equals -2. And if I change it to 0, notice my equation, y equals 2x. There's nothing there. The b number is now 0. We cross right at y equals 0. So draw those lines in on your graph paper. Okay, back to our notes. Pause the video and draw in your graphs of each equation. So what changes as the b number changes? What does that b number control? It controls the y-intercept. The red line has a y-intercept of 3. The blue line has a y-intercept of 1. The purple line has a y-intercept of 0. The green line has a y-intercept of -2. The m number in all of these equations is 2. What stays the same? The steepness of that line. Also, if it's going uphill or downhill. And the steepness of the line in math, we call that the slope of the line. Go to your next graph. Okay, I'm going to go back to my website so I can graph all those lines quickly without plotting a whole bunch of points. Notice on the top of page 2 of the notes that the b number is always -1 in those equations. So I'm going to set the b number to be -1, and the m number changes. So the first one, y equals x minus 1. When there's just an x there, that means that the coefficient is 1. Y equals x minus 1. There's the line. Y equals 2x minus 1. So I'm going to change that m number. What happens as I change that m number to 2? The line gets steeper. If I change it to 3, the line gets really steep. Now if I go back to make it a decimal or a fraction, 1/2 x or 0.5x, notice what happens to the line. And then if I make the m number 0.2 or 1/5, oops, that's 0.3. I can't get it. It's right in between there. So let's go back to our notes and draw these lines in so we can talk about them. You may want to pause the video to take some time to draw your lines in well. One thing that I didn't talk about over here is what about that b number? What stays the same in all of my lines? Well, the y-intercept. It crosses the y-axis at -1, all of these lines. Okay? What changes as the m number changes? The steepness, or in math we call that the slope. Notice that the m number was always positive. This was positive 1. All these m numbers were positive. What effect did that have on the graph? They all went uphill. From left to right, they went uphill. From left to right, they went uphill. What happened when the m number was 1, the blue line? You'll notice that it's a 45-degree angle. When the m number is 1, you'll have a 45-degree angle going uphill. What happened when the m number was greater than 1? So the purple line and the pink line, they're steeper than a 45-degree angle. And what about when m was less than 1, a fraction or a decimal less than 1? You'll notice that your line is flatter than a 45-degree angle. Okay, let's go back to our website and graph our next bunch of equations. In this set of equations, our b number stays constant at +3. Notice that makes our y-intercept be +3. So let's start playing around with our m number. They're all negative. All the m numbers are negative. So let's see. We'll start with -1. Y equals -x plus 3. And then we'll make that slope -2. It's going downhill even steeper. Make that slope -3, even steeper. Now let's make that m number be -1/2, or -0.5, right there. And -0.2. There. So take a minute to graph all of your lines on your notes. Again, feel free to pause the video to get your lines in there. My lines are not that straight. I'm trying really hard to make straight lines for you, but you'll have to imagine straight lines. Anyway, what effect did the negative m number have? It made the lines go downhill from left to right. All of them go downhill. The negative m numbers make you go downhill from left to right. The b number made us cross the y-axis at 3 for every single line. Notice that the blue line had a 45-degree angle headed down. The purple and pink lines were steeper than 45 degrees. And the blue and green with fractions were flatter than 45-degree angle. Okay, let's look at our last set of equations. I'm going to switch over to the website now. Okay, first equation, y equals 0x plus 2. So the m number is 0, and the b number is 2. Notice that when you take 0 times x, you just get 0. So that middle term drops out. You just have y equals 2. Okay, now let's try the m number being 2 and the b number being 0. Okay, next one, y equals 0x. Again, when you make that m number be 0, your equation is just y equals 0. Okay, how about y equals x? So to get that, we'd have to have an m number of 1. Y equals x, y equals 1x, same thing. And then y equals negative x, or y equals negative 1x. Our m number would be negative 1. Y equals negative x. I first want to look at the two first equations. I've drawn them in black and blue. I want to talk about the difference between y equals 0x plus 2 and y equals 2x plus 0. What happens when the slope is 0? The m number is 0. Well, this whole term becomes 0, leaving us with just y equals 2. So no slope, a flat slope. That's what happens when you have a flat slope, a slope of 0. What about when the b number is 0? That means your y-intercept is going to be 0, and your slope is 2. You're going to have a rather steep slope. I'm going to pause the video so that I can draw in the other lines. Okay, y equals 0x. When the m number is 0, and there's no b number, so the b number is 0, you're going to cross the y-axis at 0, and you have no slope, a totally flat line. Let's look at the pink line. When the slope is 1, and the b number is 0, you're going to cross the y-axis at 0, and you have a 45-degree angle going uphill from left to right. Let's look at the orange line. When your b number is negative 1, when your m number is negative 1, and your b number is 0, again, you're going to cross the y-axis at 0, and it will be a downhill 45-degree angle if your slope is negative 1.